Hi, so we're going through PAP 2012, going through sections D to E of question 22. Okay, so in part D, we are told now that you have a frictional force of magnitude 1 Newton for when x is greater than or equal to 0. We're asked now to sketch the velocity versus displacement in this case. Okay, so we're going to start with, as always, from x equals 10. So let's consider what happens. So as always, nothing changes except for the fact that we're going to have, well, there's a force accelerating it of minus 10 newtons, but there's going to be a frictional force of 1 newton opposing that accelerating force. So that means the net force is actually going to be only 9 newtons. So what we need to work out is now the maximum kinetic energy. Well, let's sketch that onto our force diagram. So let's make this essentially a net force diagram. So instead of having 10, we're actually going to have 9 down here. So that's minus 9. And then it's going to jump down to 10 when we get to 0, because there's no frictional force below 0. So now the actual work done is not 10 times 10. It's actually this area here, add this area here. So that means the kinetic energy maximum will be equal to the total work done up to this point, as always, because it stops at 10. So that work done is now not 10 times 10, but 9 times 10 plus the area of our triangle, 10 times 10 over 2. Well, that's 90 plus 50, which is equal to 140 joules. Well, therefore, how do we find the maximum velocity? Well, we know half mv max squared is 140, and therefore v max equals to the square root of 280. Okay, so when's it going to achieve that maximum velocity? Well, we know the maximum velocity is achieved at minus 10, so that's going to be down here. So we're going to have minus square root of 280 corresponding to the value of 10. Okay, so what's the speed going to be at x equals 0? Well, he has a force of 9 newtons acting on a mass of 1 kilogram. It's going to have an acceleration of 9 meters per second, or we can just work out the kinetic energy. So it gains over from moving from x equals 10 to x equals 0 as a force of 9 newtons acting for a distance of 10 meters. So it's a work done of 90 joules, and that corresponds to a velocity of the square root of 180. So at x equals 0, so the change in kinetic energy is, as we just said, 180 joules, which is equal to 1/2 mv squared. Sorry, not 180 joules, 90 joules. 90 joules coming from the fact that you had a force of 9 newtons, so it's a 10 newton plus the resistance of 1 makes it minus 9, over 10 meters, 9 times 10 is 90, and then times by 2 in square root implies the velocity is the square root of 180. So that means we're going to actually be at a speed of minus 180 at 0. So it's going to be linearly going down like this because the acceleration is constant. And then we're going to come down as the force becomes non-constant to a minimum here. Okay, well, we know that there's going to be a point over here between minus 20 and minus 30 where the velocity is 0. That's where instantaneously at rest. So it's going to come down like this and intersect here. Then what's going to happen at the top? Well, the above bit's going to be exactly the same because it's still the same force acting symmetrically, just in the opposite direction. So we're going to accelerate it into a positive velocity now, and we're going to have the same maximum at the square root of 280, and it's still going to hit the y-axis at this time the positive square root of 180. So it's going to have a maximum here at minus 10 by symmetry. So it's going to come up like this, have a maximum there, and then come down to here. But then what's going to happen here? Well, now think about it this way. So before, we had a negative velocity on a stationary object. So it just caused an acceleration, so the friction opposed its motion. However, in this section, we actually have a positive velocity, but a negative force. So that means the friction and the force are going to act in the same direction. So that means we're now going to have a force of 11 newtons on it. So how can we find the point D where the particle stops? Because we actually now realize we have a stronger resistive force. It's going to stop before it gets back to the place where it started. So work done is force times distance. So that means 11, the net force, times d, must be equal to the net force. That's the change in kinetic energy. So that's 1/2 times its mass times, well, it's at speed of 180 square rooted, so 180 square root squared. And this implies that d is equal to 8.2 meters, to two significant figures. So it's going to come down and stop here, just before the 10 mark. And finally, we're asked, how many meters does this object travel for x greater than or equal to 0? Well, that just corresponds to here and here. We know it's gone from 10 to 0 here, and from 0 to d, which was 8.2. So it's 10 plus 8.2, which gives us an answer of 18.2 meters. And that is the answer.